Okay, so the PowerPoint is about updating data, about updating your database, really. Your database being your tables that you have in SQL. Um, so the commands that we use for that, insert, we used in like the first lab. Update, I think I meant this was mentioned in a previous PowerPoint, and the delete command possibly. But we should also mention the drop, because you can drop table. Now, what we haven't, this commit and rollback, we haven't really discussed those before, so maybe it's a bit worth mentioning. The idea being that in a relational database which has multiple users, and so it's quite possible you could have multiple users working on a industrial scale database, on a site somewhere with multiple users. You have to have some way of making sure that two users don't try and update the same record at the same time, because that could introduce a problem, right? I mean, you could even lose the record. And so what happens with these relational database, well, actually all databases that are used with multiple users, is that we have this sort of system of a commit and a rollback. And so the idea is that when somebody wants to make a change to a record, first they have to sort of block the record so that nobody else can use it. And it's only after they block the record, they've sort of and then they've done their change, then they can make a commit. And the commit will only happen if nobody else is trying to access that record. Now, the idea of the rollback is that you can go back to the point before the record was changed and start again. So that's the idea of the commit and the rollback. The idea was so that we didn't get damage to our database from multiple people trying to work on the same record at the same time. As for this course, you won't be using those commands. So it's interesting, but you don't have to do it. Okay. Now, update. The idea of update is you have a live database system. When I say live, it's not just about you running select statements so that you can see what's in the system. It's that maybe you want to actually change the data. And so how you would change the data is with update. And I think we mentioned this in the previous lesson as well. And so update comes with two parts. So first you have to say the name of the table that you're going to update. You do that with the update part of the clause. And then you have to do the set. And the set is you're going to set a particular field in that table which you are updating to a new value. And so I think, do we have an example of that here? Yeah, here we do. Update. So supposing we had a table that was called level 1 customer, then it has a field or column name which is called customer name. So if we wanted to change, so we're not adding a new record here. Adding a new record would be using insert, and you used insert in, like, I don't know, lab 1 maybe. So it's not the same as that. What we're doing is this record is already there, but we are going to change it somehow. So in this case, maybe the customer has changed their name or changed the spelling of their name or something like that. So the customer exists in the table, and they exist with a key field with an ID of 842. And so that customer only, we're going to change the name. I think we're listening to somebody's family there. So I'm just going to mute that. You can unmute yourself if you want afterwards. Now, the idea of a compound condition, you've seen this before. If I went back to the previous slide, actually, if I went to the previous slide, the where part of that condition is quite important. If we didn't, we could do an update without the where, but if we did, then what it would do was it would change all of the records in the entire table to have that customer name, and obviously that would be a bad idea. And so the where condition, we're typically going to only change the details of a particular record. So it's going to be quite it's just logical. It's like common sense that in the where condition, you would state what is the key field so that you got the record that you wanted to change. Now, here we have a compound condition in our where, and that's we're only going to change the credit limit if the balance is less than the credit limit. And so, yeah, so that's what that one is doing. And it's only going to do it to one representative. I mean, yeah, business rules. SQL is all about applying the business rules. So, I mean, your accountant or your business manager would come up with some kind of a rule like that, and then you would apply it, right? So, I mean, what I mean is the accountant says, well, if they have a credit limit of 2,000, we're going to change it to 8,000. Yeah, just like that. Um, so the insert command we've already talked about. That was back in lab 1. That's how we add a new record to the table. The select command, again, back in lab 2, maybe lab 1, that's where we get to view a new table. Now, actually, I think I mentioned this in a previous discussion, is the select command in SQL, the results of the select command are always a table. Now, it could be a table with just one row and one column, so it just looks like a single thing, right? But that the thing is, everything is a table. All of our data that we're getting data from is a table. All of the data where we um, our results, our output is always going to be a table. And that's kind of cool because it means that we can have this idea of what we call sub select. That is that we can select using the input of a select statement can be the output of another select statement. And yeah, you don't have to do that in this course. Don't worry. All right, so here we are. We're adding a new record, and hopefully this looks familiar to you by now. This was like lab 1, right? Well, I mean, we had a different table, but I mean, this is the ideas behind it, right? You have a record, a table, and you've already, in this one here, notice we're not saying what fields we're going to put the data into, and that's because we're putting the fields into all of the table, all of the fields. Sorry, putting values into all of the fields in the order that they are presented. So that thing about stating what fields before the values, that allows us to sort of change the order or also change the number of fields that we add data to, because you don't have to do it to all. There's a little bit more about the commit and the rollback. Before you actually make a change to the table, there must be a commit. And this is required for multi-user applications so that we don't sort of ruin the database by two people doing the same thing at the same time. Rollback takes us back to before the commit. The changing and deleting of existing rows. Now the delete command, we got two things that we can do for deleting tables. Partial deletion, we use the word delete. Delete will delete a row or rows that meet a criteria, same as a select criteria. So a delete statement kind of looks like a select statement, delete from, where. And so that's the and that's why you can. So it's working with rows in a table, and so you can delete all the rows in a table, or you can delete some rows dependent on some criteria. We got another command which we call drop, where we drop the entire table, and not only is all the data gone, but the actual table structure is gone as well. Delete doesn't do that. Delete leaves your table behind, but just no data in it. Okay, so here's the example. Doesn't it look like a select statement? Can you imagine select from level 1 customer where customer number is equal to 895? Yeah, and just give you a record. Well, this
Sir?
will do is it will delete that record. Yes, Saida.
Oh, so it will delete the customer whose number is 895?
Only that record. And so I told you it looks kind of like a select statement. You could actually test your delete before you run it by changing the word delete to select and seeing what happens. And see what's there. And then when you change the word select to delete, those records will be gone, right? Next time you try. But so that you know that you're deleting the right thing. Uh, I hope, are you following me there? Does that make sense? What I just said?
Yes.
Yeah, yeah, okay,
Sir,
good.
so what happens if I accidentally delete everything?
Then it's gone. So I mean, you can reinsert it. You know what I mean? Use the insert command and put it back in. Be careful with your delete, obviously. I mean, it is updating the table. Um, and I did mention here the drop. Dropping a table is going to remove the table and not just all the records in the table, but it's going to remove the actual table structure as well. And yeah, so if you've dropped a table and you want to put it back, you'll have to create the table first. If you delete, then all you have to do is insert. So delete is the opposite of insert, and drop is the opposite of create. I hope that makes sense. And that's what we talked about today: the update, the insert, the delete, drop, commit and rollback. As I was saying before, we don't have a practical use for commit and rollback because none of you are using a multi-user database. If we had like an industrial database that we're on some in the cloud or on a server here at the college that everybody has access to, then commit and rollback commands will be involved. But we don't, so you don't have to worry about that. You'll have no practical use for that in this course. Now we
Sir,
got a couple minutes. Yes.
so if, for example, if the college has a database on us, and if it wants to recognize us according to our age, will it like will we create a query or like some kind of
Well, in
distinction?
practicality, yes, a programmer could just write an SQL query, could get a programmer who had access to the SQL database, and which is, we say it's in the back, right, in the background. It's in the back end of the system, so that users don't see or access the database directly. They access it through tools, and they're not able to sort of delete things. But um, so a IT um, maintenance person, for example, the uh, may have the credentials to actually and permissions to actually update and change data in the database. And so yeah, they could probably just run some SQL queries and look at things in there and change things. Can you see how dangerous that would be, especially at a college, right? Where so I mean, obviously there's got to be some sort of controls on that, on who gets to do what, and you can
Sir,
do a
don't
whole,
give
oh,
ideas.
well, you could do a whole lot of stuff about the security on that. So, for example, if you're running a properly secure institution like this, the IT people should not have any access to the data. I mean, all they have is access to the programs. Um, the only people who should have access to the data should be people in the registration office. But so having said that, if you were an IT hacker, yeah, you could get into the database and do a lot of sort of whatever you wanted to do. Um, Now, the way that that would actually work for the people in the registration office is because they're not IT people. They're not going to be writing SQL commands. So what'll happen is somebody will be writing HTML and JavaScript and PHP, which will be presenting for them forms, which they click and do searches. All the searches will be in the background. They won't ever see any SQL code, but the SQL code will be running, but it's running sort of, it's being called by our PHP and our HTML and JavaScript. Does that make sense? That's the way that's going to work. So your non-IT users are probably never going to see the never going to see the SQL, but it's there. It's there. It's just running behind, and only the IT people sort of do that. All right, does that make sense? So now I was just talking about sort of security of systems and things like that. Generally, you don't let the developers, the people who are creating the systems, you don't let them have access to the live data. So they will work with some old data or some made up data or something like that. When the system goes live, um, you have people who maintain the system, but they're not the same as the developers. Does that make sense? Otherwise, you have a opportunity for insecure systems. Yeah, I mean, you could pay somebody $30 and get them to change your fail to an A, right?
That's plagiarism. No, not plagiarism, but that's against college law.
Well,
Wait.
it's against the law, right? I mean, I'm
Yeah.
sure not just college law. You might find yourself in jail if you did that. So yeah, okay. Um, so we've got some queries here. Uh, and let's just have a look at a few of those and see how they work. So in this one, in lab 3, we should actually get to working with more than one uh, one database. Yeah, and actually here it is. And this was one that I made a video about this one. Each order lists the order number, order date, along with the number and the name of the order.
Yeah, that was in lab one or two.
It showed up in lab one or
For
two as well. Shouldn't have, right?
y- yeah,
How
because we
about
had to.
that?
I was the one who asked you that because we have to draw the table.
Yeah. Anyway, so that would be done with something like this, right? Uh, you're going to select the fields that you want from the two different tables. You're going to say what the two different tables are, and then you're going to set the two different tables together. Now, you don't believe me on that, so we could recreate our database. I'm not keeping a database up there. I'm recreating it every time. I mean, I guess one benefit of that would be that I could theoretically I could sort of change it every time, right? So if I maybe I shouldn't change shouldn't do change that one. Maybe I should. Anyways, SQLite. If I go to SQLite online and run this, create this thing again. Okay, so create our tables and run that. There's our tables, um, and then the lab. It's the query itself here. Lab. What was it? It was. Oh, which one? Which query was it? Oh, those are lab two. It was lab three. It was like the first or second query, right?
Lab three, question one.
Yeah, there it is. And so that's just going to get values from the two tables. Let's see how it works. Copy it in there. And there's our, okay, the order date, the order number. Now, actually, the order date became of interest to students because there's like 5 different ways you can do dates in SQL. And how have we sort of done that? We'd be able to see that would be in the order table. If I looked at the order table, um, the order date, can I see it? It's a date time. You see it's date time. Do you see how it's showing up there? Date time at 8. So there's lots of different time sort of uh, data types, and the one that we're using here is date time. And the way date time works is the year comes first, then the month, then the day, and then there's actually some time afterwards. And so that's why that is like that. Anyway, so there's some stuff. You can actually see the queries there. Oh my gosh. So yeah, no sort of big mysteries. Um, uh, Maybe just one more. Each order lists the order number, the order date, the part number, part description, the item class for each part that makes up an order. Number 4. Wow. So that one, have we got any that have more than 2 tables? Yeah, it's this one here. That's question 4. Question 4, for each order, list the order number, the order date, the part number, the part description, the item class for each part that makes up an order. And if you look at that, that actually requires you to the details of the part are common to the order line table, and they're common to the part table, but they're not actually in the orders table. And so we have to join the orders table with the order line table, and we have to join the part table with the order line table. And so that makes it kind of interesting, and that gives us this kind of thing here. That's a cool one. What I like about that one is we got 3 tables sort of working together to get our result. That was no question 4, and you got something like that. So we have our order number, our order date, the part number, and the part name, and the class. And so yeah, that's kind of cool. All right, so any questions? I think I'm going to stop. Somebody's trying to call me. Oh, well, don't think it's anybody in the class trying to call me. No, probably not. So it'd be somebody else. Um, any questions on this? Because I'll stop recording.